What do you start with? Very good. You start angle BAC, congruent to angle DAC. Now, I don't know how many of you guys are actually taking it to heart when you have proof stuff out of the textbook. Make sure you draw the picture. It is so important to draw the picture so that way as you're going through the list of things, you mark them. And that way you continue to mark them off. So we marked off the two angles. We go to the next one. The next one talks about AC being perpendicular to BD. That tells you that there is a progression because of the perpendicular. So you read your progression sheet and look for where it says what to do when you have perpendicular. Well, when it says you have perpendicular, it says to first state the right angles that are formed. So you need to reference the diagram where those two guys are perpendicular. They're perpendicular right there. When your angles don't, excuse me, rephrase this. When your angles can't be lettered by one letter, when you can't use one letter for an angle like this, how many letters do you have to use? 3. So if I go through this when I start writing them down, if they're perpendicular, if I say angle ACB and angle ACD are right angles. That is the definition of being perpendicular, because that's what your sheet tells you to do. Okay. Now, if you said angle BCA and DCA, are you okay as well? Absolutely, that's fine. It's the same thing, right? As long as you're consistent in how you letter them out. From here, your sheet says to now say that those two angles are congruent. So, angle ACB is congruent. Angle ACD, because all of the right angles are congruent. Back to the diagram. In the diagram now, there is a glaring, obvious thing that you can state. Louder. Reflex, like I jump at you and you go. Ah! Reflex prop is okay to use. Now, your diagram marked up. Which of the 4 do you have? That's why we look back and forth to the diagrams so you can figure out how things are marked. Here you've got angle, side, angle. You've got 2 angles and the side in between. What did they say? ABC. Okay. Angle, side, angle. 2 givens, 1 progression, reflexive, done. Okay. We'll skip the parallel for now. And was it this hour? You guys have angle bisector on your sheet, right? Yeah. Okay. For some reason, I forgot to give that one to 9th hour. Oops. What's that? You're right. I don't. You don't have angle bisector? Oh, I must not like you guys either. I apologize for that. Sure. It is kind of the same thing, but just to be on the safe side, make sure that we have this. I think I just absolutely overlooked it. I think we said segment and angle bisectors are basically the same thing. One does a segment, one does an angle. Just so you have that on there. Just so you have it on there, if given angle bisector, you state some angle is congruent to some angle. Okay. When you had a segment bisector, it was segment congruent to segment. When you have an angle bisector, it's obviously angle. Excuse me. So if I say BX bisects angle ABC, if I just say something real simple like that, you obviously have the given BX bisects if that's the bisector, what does it do to the large angle ABC? It cuts it in half. You know, I just realized where I got that silly line from. Without you guys knowing. Well, I know you noticed, but have you ever seen Pee-wee's Big Adventure? Really? It is the cheesiest movie of one of the craziest, cheesiest movies of all time, but it is so stinking funny. It's really good. We were watching that last night with our boys, and our boys were laughing hysterically. And then he knocks over a motorcycle gang of motorcycles, and they all take him inside the restaurant, and they're saying, "Let's kill him." And they're like, "Yeah, like ah." And then they go, "Let's hang him, and then we'll kill him." Ah. And then they're like, "Let's." Everybody says, let's stop him, and then tattoo him, and then going on and on and on. And then Pee-wee's on the ground and goes, "I say let him go!" And they all yell, "No!" Anyway, so I thought it was really funny. I don't know if I got it from there. I just remember here. I saw it last night, and I was laughing. My wife was like, "What are you laughing at so hard?" Like, they do that in class all the time. Just like dance around like a moron. Well, besides that. Anyway, angle A. We never get sidetracked. You guys are gonna miss me in like February. I'm gonna hide. Oh. Now, the reason that it's just definition of an angle bisector. Yes, sir. Oh, I forgot to print it. I will do it today. I'm sorry. Forgot. When you have an angle bisector, obviously, I think I just overlooked the fact that we've done so many of them. I didn't realize that it wasn't officially on our sheet, so I apologize for forgetting that. Like I said, I'm old and forgetful. So, anyway, it's really simple. If you're given an angle bisector, you say the two angles that are congruent. Y, definition of an angle bisector. Follow through. So back to one we were working on. You're given angle V and angle Y are congruent. We mark it. And I'm not literally hiding from you guys next semester. I'll be here. No. I'll be here. And then you go to your next given. It says WZ bisects. What's that? I will, yes. I'm just writing this one down first as my given because now that I know where the bisector goes, I go to that angle that's cut in half and I mark those two angles. So if it's bisecting VWY, those two are going to be the same. So now I write down what those angles are. And that's what it looks like, just definition of angle bisector. Okay. So now, when you have your diagrams drawn up and you start marking them through, you'll notice you've got two angles. Well, if you have two angles, you know it's not side, side, side. You know it's not side, angle, side. It's either going to be angle, side, angle, or angle, angle, side. Well, look at this picture. What does it have again? It has the reflexive property. Good. So you've got the reflexive property at WZ is congruent to WZ. What is it then? Angle, angle, side. Very good. Angle, angle, side. You're just following through your stuff. Right? Okay. Now, this one was a little bit different than a traditional perpendicular progression. The traditional perpendicular progression that we've been doing stems from when you have two segments that run into each other and you get two angles from that right away. In this example here, the two segments run into each other, but you're only winding up with one angle each time. So what happens is, instead of it being perpendicular, right angles, congruent, perpendicular, right angles, congruent, 6 steps out of those first 2 statements. What happens is you have to state those 2 sets of right angles independently, and then they're congruent to each other. Okay? It's a very, very subtle difference. Not difficult, but just a little different. So PQ, perpendicular, QS. So again, as we know that those are perpendicular, your sheet says state the right angles that are formed. Well, there's just one right angle formed at PQ and QS. It's at angle Q. So I would say angle Q is right angle. Do I have to use more than one letter for this one? No, I don't, because it's just one vertex. There's only one angle Q. It's not sharing a vertex with something else. Whereas opposed to like T, I can't just say angle T. So I go to the next one. RS and SQ are perpendicular. Oh, I forgot to write definition of perpendicular. Sorry. Here's your right angle again. Do you have 2 right angles now? Yeah. What do you know about all right angles? Which means that we can say that they are congruent. You're not wrong by saying that they equal 90, but when you start looking at your proof, usually 90 degrees isn't going to get you anywhere. Okay. Now you've used up those first 2 statements. It just took 5 to get to it. So you go to the next thing. Midpoint. Midpoint was the first thing we did. Midpoint was one of the first things we did. If you have a midpoint, what's happened? What happens? What do you have to state? I forgot the letters. PR. So PT and TR. And now go back to your diagram. You have an angle and a side. Is there any way to find another angle before it, a side, or actually, if you look at where it's at, it has to be an angle before. Because that right there, that side is not between the right angle and anything. So where's the other angle that we're going to get? You have a picture of what it looks like in your progression sheet. Yeah, they're vertical angles. Remember, guys, whenever you have that bow tie style, you have vertical angles right here. Okay? Shh, guys, just write it down. QTP. And STR. And now we have our triangles PQT. And this one was angle, angle, sine. Very, very, very straightforward. It all goes back to making sure you can draw the picture. Fill in the blanks. So, excuse me. Let's talk about this whole idea of this parallel thing. We've done parallel before. It's been about a month or so since you guys have seen parallel lines. But remember, when we did that, we did parallel lines cut by a transversal. When we had parallel lines cut by a transversal, we had all those different angle pairs. Okay, you remember that? Corresponding, alternating interior, and so on and so on and so on. Okay. So let's take a look at that real quick and explain where is this going. So you might want to write this down in the notes here. We'll go back to this proof here in a second. So here, do you guys remember what these symbols mean? The little arrows? It means parallel, good. So when you have parallel lines, and then the line that goes through them, remember the line that goes through two or more parallel lines is called a transversal. So here we have what we would say is two parallel lines are cut by a transversal. When that happened, you had four different angle pair relationships. You had corresponding, alternate interior, alternate exterior, and consecutive interior. Okay. You had those four different angle pair relationships. Now, if the lines were parallel, what would you say about corresponding angles? Or better yet, what were corresponding angles? Let's start with that. Yep. Same spot, yeah, same position. For example, if I say those two would be corresponding, correct? Same position on different lines. Are those congruent or supplementary? Congruent. You had a 50-50 chance of just guessing. Corresponding angles were congruent. All right. Alternate the interior. Well, are they on the outside of the lines or the inside of the lines? Inside. Alternating means they're on opposite sides. And those guys were congruent. Okay. Exterior, same thing, but just on the outside. Those guys were congruent. But the last one, when you had consecutive interior, those guys were always what? Supplementary. They're not always congruent. Remember when we did our tick mark stuff? If this guy was here, that's its vertical angle. And then if I switch side, that's its alternate interior, and then here. Then this guy was here, alternate. And that's why all that worked. So consecutive interiors were supplementary. Now, to be honest with you, when we have these parallel lines that get thrown into proofs, more often than not, it's just two types. I don't think you're ever going to see something with a consecutive interior, so I'm not going to really worry about it, nor do I think we're ever going to see anything with alternate exteriors. What happens is it's usually one of these two angle pairs that you'll get, corresponding angles or alternate interior. And it usually depends upon what the picture looks like. Okay? And that's kind of the idea of what I want to throw in our progression sheets. What to look for when you're given parallel lines. Okay? So let's do a square. And I'm going to write this. If given parallel that looks like this. There's usually two different types of pictures. And I think that's going to encompass pretty much all the things that we're going to come across. A lot of times you're going to get ones that look like this. That just means opposite sides are parallel. Are we okay with that? It's a quadrilateral with opposite sides parallel. And then a lot of times what they do is they put a diagonal in. Okay? Now, if you were to overdraw this to see what was going on, which you don't really need to, if I do this, bless you, that's two parallel lines cut by a transversal. You guys okay with that? It gets way too messy if you do it this way. So here's what I normally do. Do you guys agree that if I follow my parallel to the transversal to the parallel, it makes Z? Okay. Now, this Z could be the regular Z or a backward Z. It's okay. It's still kind of a Z. Now, where it changes directions, wherever it changes directions, those are your alternate interior angles. Where that Z changes direction will always be your alternate interior angles. Bless you. Okay. So if it looks like this, then we're going to have, we can state angle congruent to some angle, because these guys here, where it changes direction, are alternate interior angles. But here's where the weird part comes in of what you write for your reason. This is the one that kind of stinks. So write it all. If two parallel lines, I'll write this out bigger, then alternate interior angles. If you have to write this out about having alternate interior angles, you have to put this all in. If two parallel lines are cut by a transversal, that's what that symbol stands for. The double arrow, the two lines slash through it with arrows all the way around. Because if you just put it as this, what does that mean? Not equal. Very good. All right. We got to put the arrows on it to show that there are lines and stuff. Are you trying to act tough? So we would say if two parallel lines are cut by a transversal, then alternate interior angles are congruent. If it makes a Z, whether it's a forward Z or a backward Z, wherever that Z changes directions, those two angles will always be congruent if the lines are parallel. Okay, so if my Z was going the other way, it would look like that. These would be the alternate interiors. It works. So you look for the Z. Okay? You look for the Z. Could the Z be turned on its side? If the Z gets turned on its side, does it look like that? Kind of an end then, isn't it? Is it still where it changed direction? 740. I don't know. That's why I have the progression trees. What we're looking for. Right? Am I okay with that? Yes, sir. Yeah. So we're saying if you're given parallel and you get a diagram that looks like that, you want to. I don't know if you guys have a highlighter or something like that, or be able to darken in the Z part. I would try and darken it in and go from there. I have 3 highlighters I can share. That's my yellow one. Sorry, I already got it. Guys. All right. So pass those around so you guys get the idea so you can see it. This is one that shows up pretty regularly, just like the one that you did last night. The other one that shows up pretty regularly. The other one that shows up pretty regularly is one that looks like this. Can I go to a clean one? Sometimes you get one that looks like this. So if given parallel lines that look like this, you can always get another sheet. I got plenty of other sheets. Sometimes you get one that looks like this. It's in the bucket. In the black bucket straight to your, should be in there. So sometimes you get ones that look like this. Think of it as pennants. A couple of pennants hanging in the, like a flag. A lot of times you get them where these parts are parallel. Okay. A lot of times you get ones that look like this. These are setting you up for corresponding angles. You might, that means you'll get these two. Okay. Now it could be these two sides are parallel, and it could be going back this way being parallel as well. That means these two guys would be parallel. So if you see ones that look like flags or mountains, or if they're pointing downward, they're like bangs. You know, blah, blah, blah. That whole thing. That's the idea of what that looks like. You recognize that picture, it's setting you up to use corresponding angles. So here, if I call this angle 1 and angle 2, I can say angle 1 and angle 2 are congruent because of corresponding angles. So I would say, let me rewrite this. Same symbol, two parallel lines, cut by a transversal, then corresponding angles. Here. Those are usually the only two that you'll see. Actually, those are the only two that you're going to see. I don't think we've ever done one that had an alternate exterior, nor have we had to do one with the consecutive interior, because then you start dealing with supplementaries, and then you have to go back to the algebra, and I don't think we need to worry about that. So the two that you would look for are either corresponding or alternate interior. Does that help a little bit as far as what to look for when you're having that parallel? So now if I go back to the problem we just started from the proof, we go back looking at here, you're given, you had two sides that were congruent, and then you were given two sides that were parallel. If you look at that problem and you trace the ones that were parallel, Z, parallel. Where it changed directions will be the angles that are congruent. Where it changes direction means those are the angles that are congruent. I can't say Q and T, I have to use three letters because there's multiple vertices there. So what I would do is I started like I would normally. QR, congruent, TS, given. And then I go to my next part. QR, parallel, TS. So I've got congruent, And again, as I follow my Z, I follow the parallel to the transversal to the parallel. Wherever I change direction, those angles will be the ones that are congruent. So I label them. Angle RQT. If I say angle RQT, what would the match have to be? If I go RQT, what matches letter-wise? TSQ's go the other way. STQ. Remember, I'm starting here. I was going from R, Q, T. Out, in, down. Out, in, in. Hi. I'll be your tour guide today. No. No. Oop. Got to put the hole. No. E-I-E-I-O. Hey, guess what else happens with these? Well, you're right. It's going to be SAS, but no. Notice what happens with that transversal. Isn't that transversal shared between the two triangles? Yeah. It's always reflexive. Transversal on this thing is always reflexive, and I'll put that in there also. So I can say QT congruent to QT, reflexive property. And just like you said, side angle side. Follow the stuff. Triangle QRT. So maybe on the progression that had the Z, put a hint next to yourself. That transversal is always reflexive. So it might not be a bad idea to remind yourselves that you have reflexive at that point. Not at that point, but at that spot. So you're kind of looking at that, by looking at that diagram, you'll be able to pick out a couple of things. Okay? Yes. No, all I'm saying is just I'm putting like a little reminder, so that way you remember that this part here, use reflexive property. It's just one of those things that, since you know that it's shared because you make the Z with it, since that's the transversal between those two triangles, that's always going to be reflexive. Whether it's the Z normally or the Z backwards. That shared side where that transversal occurs is always reflexive. All right, so if it is, that's reflexive here. If it's going the other way, it's reflexive. If it's upside down, it's still reflexive. If it's going like this, it's still reflexive. When it goes in between those two sides like that, if they're all capped off like triangles, that part will always be reflexive because it looks like our diagrams that show the reflexive. Okay? It's just one of those little tips and tricks and things that show up from time to time. Right? Now, after you see that, not that bad to do a parallel, is it? So on the one that you guys now, guys, now one thing that I kind of neglected to do was renumber all of these. I'm going to go out on a limb. I know I'm assuming a lot right now that you guys can count. Now there's only 8, and I don't think anybody's missing any fingers, so we know we can at least get to 10 on our fingers here. And, well, that's why I try to hide my scissors from you. Anyway, so what I want us to do tonight do numbers 1, 2, 3, 7. And the quiz will be on Friday. Now, just like we've been doing, ladies and gentlemen, you're not going to be here, you'll do it tomorrow. Oh, come on. If you're going on vacation, trust me, you want to get done before you go. No, that's not vacation. He's big guy. I'm messing with you. No, whatever. I get you. So, oh, sorry. So, these are the complexity that you guys will have in the quiz. All right? Progressions, givens, reflexive sides, things like that. Now, excuse me. If you think you're doing just fine, work through a bunch of them. I plan on going through the 4 tomorrow. I think 3 of them have the parallels to it. That way we can kind of revisit that a little bit. And then we'll start working more of them in class to prep out for the quiz. The quiz is just straight proofs. You will be completely on your own. There is no fill in the blank on this one. Okay? So, if you haven't done so in the past few days, please take a picture of your progression sheet. So in case somebody comes up and steals yours, or you spill coffee on it, or a dog eats it, or the wind blows it away, or a goose comes over and eats it, or poops on it, or something. A goose? Now, I will say we have a pond pretty close to my house. And for some odd reason, geese like ponds. And they poop everywhere. Some odd reason. So the other day, Moose and I were fishing our pond. And we were walking back. And all of a sudden, the geese all decided to fly away. And we're talking hundreds of them. So they start flying away. And when geese fly, what do they normally leave behind them? Poop. So we didn't get pooped on, thank goodness. But I can see, if you're walking, I got my progression sheet, read my progression sheet, oh no, it's a plausible thing. It could happen. No, but if you know that you launched your progression sheet, what hour did you have class with? 6, 7. If you knew you lost your progression sheet when you got to school, you went, oh, crap, literally crapped on it, or whatever. You could come in the morning and say, Murphy, I lost my sheet, but I got my picture, and I have a blank when I was filling it in real quick. You have to fill it in. I'm not going to use your phone. But that's why I look at it as a safeguard. Always back up your documents. Nowadays, you guys use the Google. The Google automatically saves stuff. Well, for the most part. Back in my day, you had to hit save as to make sure you do all that stuff. Okay? Are you trying to grasp me? short arm?
No.
Yes, I'm a dinosaur. I think I figured that out. Yeah, got it obvious. But as I was saying, take a minute, take a picture of it, so in case you lose it, it would behoove you. Yes, sir. For what? Yeah. Yeah, we still have, we're not done with chapter 4. We got a ways to go. Chapter 4 still has, once we get past this part, next week we're going to do some what are called corresponding parts. So if you wind up with what will happen is, once you get past a triangle being congruent, here we've said that we have two triangles that are congruent. Once you have that, that means then all of their corresponding parts between the triangles are congruent. So I can take extra steps. After I say that QRT, bless you, QRT is congruent to TSQ, then I could say, oh, angle S has to be congruent to angle R because they correspond to one another, and so on and so on. That's just the extra steps we'll get to. So what will happen is, bless you, I'm going to ask you guys to prove that angle S is congruent to angle R. You have to work your way from getting to the triangles first, just run the rest of it, and then show that the corresponding parts. It's just adding 2 steps to what you've been doing. Right? Once we get past that, then we get into isosceles, equilateral, and interior angle sum stuff yet. So we're almost done with the proofs. We might have about a week or so left, maybe 2 weeks tops. But I'd say probably the first week of November will probably be we'll be done with proofs. What is that? This second is a Friday, 3rd, 4th, 5th. Somewhere in the week of the 5th, right around parent teacher conferences, just being finishing up for chapter 4 right by then. Not on, that would be what, the 9th? Does that sound about right? Whatever it is. Yeah. So we're almost done with the proofs, and then after that, guess how many proofs we have to worry about? 0. Until you get to algebra 2. Well, it depends if you guys have to do trigonometric proof or not. If you gotta do trigonometric proof, then you gotta do it. Have a good